Do you? Yeah, it's being shared.
Yeah.
Okay. I will start with reloading all of these, which will come up when I start the Docker container, but right now they are all offline, everything. And in the Docker container, we can see nothing is running now, but I can start things. And while this boots up, there are a few services. I can go to the PPT. Okay. So these are the tools that were new in this course, and I use them in this project. The whole thing is about some friends of mine who like to read poems, and this guy there, he's from an Urdu poet from 18th century, and some of my friends wanted a collection of all his poems, which is surprisingly not available easily. This guy is called the god of Urdu poetry, so he's apparently one of the best poets. But you can find books and selections of some of his poems, but all of his poems in one place is not available, at least not in print format. So I can find those poems online from various sources and then compile them. And I prepared a compilation like that. But then I got feedback from my friends that some of the vocabulary, because one reason is that literary vocabulary tends to be much richer than the common register of any language, and also then this guy is from a different time period, so the language has also changed a bit. Many of his um, phrases have been incorporated in the language as proverbs now, so that's interesting. So I'm using this ML pipeline that I built using the tools from this course to solve this. The first prototype that I refer to, that looked like something like this. So I go to some various online sources, do some web scraping, HTML pages, calling them. It's very slow, like because I need to extract a lot of pages. So I won't be showing that now, but this was what I had like in the summer. I do some web scraping and then some analysis on top of that, and then convert the data into a JSON file. And then that JSON file can be exported into a PDF or into a web application, something like. So this is not online, but this is a offline version of this HTML file, and you can go to whatever the poem number, and those things are poem titles after the number, and it shows you those poems. And there are lots of poems. Like that means book number one, and book number one has 600 poems, and there are 6 books like that. And in total, these are cumulative numbers. In total, there are about 2,000 poems. And I obtaining these was not so difficult, and then you can convert them into PDF. But then many of these words, not many, but a fair number of these words, for example, like I do not know what that means, or like maybe someone might not know what that means. So I thought it would be helpful if I can like put some symbol there, and then in the footnotes I can explain what that word means. And again, getting meaning for those words is not difficult, but the most challenging part here is identifying which words need to be explained. So for that, I'll resume this here. For that, I have this pipeline, which so far I had from the internet, I converted the JSON file, but instead of converting that JSON file directly into the PDF or whatever, I can do some analysis on the JSON file, say find all the unique words along with the frequencies they appear. And not only for this one poet, but I can do this for other poets in other writing styles in the same language. And because every poet, they have a unique writing style, but also slightly different affinities to use some kind of vocabulary. So if I compare this among, say, dozens of other data sets, I might be able to find some patterns in what kind of word this is. And what I am interested in is how common this word is. So you can combine that and get a table of words and frequencies, all the words and all the words that we are interested in, and frequencies in this data set, but also in other poets or other writers' data sets. And then these words and frequencies can be, these words and frequencies, this is a good data set, but there are no labels here that which words are common and which ones are not. So then some of these words can be sent to a server, from the server to a user who can manually label which words are easy for them or which words seem difficult to them. And then once we have generated the target labels, then we can run some machine learning algorithm on that. In the current flow, when the user submits the labels, that automatically triggers this DAG, which has two parts, two operators in it. First, it combines these target labels with the words and frequencies and generates the input file, then trains an ML model on that input file. Next, once that model is trained, then the ML flow keeps track of all these model performances. The most important part, the most interesting part here is if there are, say, 10,000 words, you don't want people to submit labels for all 10,000 words because that leaves this ML model not much useful. So we can use the predictions from this ML model to gather labels for the words which are not well classified into easy or difficult category. So that's the purpose of this whole exercise. Now we can go back and see if Docker is up. Docker is probably running here. We can reload some of these. Let's look at the Docker compose file. So I have this in the services. I have one web service. There's a Flask app, and it's exposing some port. But if you go to localhost 8000, that would not be running because we are using Nginx, which exports, which passes on this upstream data to this port. And we have Airflow running on server 8080. And that's just the Airflow scheduler. And then MLflow is running on port 5000. So we'll see if those are up now. The Airflow is here. That's one DAG. I have only one.
Yeah.
Which is active. And then this is the MLflow UI. We'll come back to that. Let's look at the Airflow DAG first. As I showed in that PDF, in the PPT, there are two operators. In the first one generates the ML input. The second one trains the model. The code for that is like this, and it is sequential. These are Python programs. I'm using bash operator with a Python command. It works okay. And then when we trigger something, we'll see the first one runs, generates some log here, and then exits with return code 0, which means it succeeds. And then it goes to the next one, which the results are logged in some ML flow experiments, which are here. We are looking at that one. And I have showed some of these metrics, the parameters, which is number of rows, how many words have been submitted, and the test mean squared error. You can also, let's look at So this one doesn't work because we do not have uh, only the Flask server. Flask server is running along with the Nginx uh,
Yeah.
reverse proxy. So these are all the words. And then before we submit these words, let's go back here and see. Currently, we have 183 words for which labels have been generated. And there are 3 columns here. Those 3 columns refer to easy, difficult, or misspelled, because some of the words might be misspelled. So that information would be gathered here, but then those words would be excluded from the ML model analysis.
Mm.
And after this, after the labels are generated, when the DAG is triggered, then that will generate this whole input file, which also has 183 words currently. One obvious thing there, what that means is that none of these 183 words are misspelled.
Yeah.
So now let's submit some of these words. So that one, I'll just go by how I feel. Uh, and it would not make much sense to you because the script
Yeah, I
is
cannot read
different.
any of them. Yeah.
Yeah, exactly. But I'll just submit some of these, and let's also mark one of them. Can I find a misspelled one? I don't know. Not many of them are misspelled, but maybe I can mark one of them misspelled and
Yeah, you can test
yeah, exactly.
markers. Yeah.
Right. So, and we had 183 words there. And once I click submit, and it refreshes, and now again you can't read the words, but these are new words.
Okay.
And now you see instead of 183, we are at
Okay.
196 words.
So you're using this labels.csv as a database, something like that.
Yes.
Okay.
And then that after I clicked submit, that has triggered. So you see the highlighted one is an old one. If I refresh the Airflow UI,
Oh,
this new column has been triggered.
amazing.
And this new column generates this file, which instead of 183 now has 195 words. Now,
Mm.
remember that because this is 196, but this is 195 because one of the word is
Yeah, yeah.
excluded, the one that we marked as misspelled. And then after generating that file, it runs an ML model. Here I'm using a simple model. I'm not very sure this model works great, but just to show the pipeline, it throws some metric, which you can also find here. And now that one means there is a new run in these experiments, and this is run 49 seconds ago. Now the number of rows are up to 194, and uh, one of these rows is the first one is the header. So that's why instead of 100, it says 195, but there are 194 rows because of the header row. So out of 194 data, the test mean squared error is 1.198, which is actually the lowest so far. Let's look at how it has been changing with respect to the number of rows. I can plot number of rows here and the mean squared error there. In the first one, it was very high because that was very few data, and also maybe all of the data was of same kind, or maybe only 1 or 2 words were difficult. I can so many. Yeah, there's no clear decreasing trend, but then this happened to be the best so far. So I'm happy. The model can be improved, and I've been thinking about what to change in the model and so on. But yeah, so that is the pipeline, and it's working okay. I
Yeah.
tried logistic regression code as well, um, but then I was using scikit-learn's logistic regression, which only takes binary labels. But I'm not restricting words appearing here only once. Some of these words might be sampled twice, and in that case, if someone marks it as easy and someone else marks it as difficult, I want that to be somewhere between the two. I want the label to reflect
Mm.
that. And then scikit's logistic regression doesn't work. So I have written a logistic regression code which can handle that and then generate similar metric, but that's not implemented here. So I showed this with linear regression. That's fine. Okay, that is all.
Yes. Yeah, yeah. Very advanced usage, I can tell. And just a couple of questions, maybe just for my
Yeah.
interest. Yeah. So,
Yes.
how did you like trigger the Airflow from your code?
Yeah.
Did you send an API request or something?
Yes. 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 Where's the Flask app? And then in the app, you see the screen again? Yes.
Yeah, yeah.
So in this one, when they submit, then I have my username password for the Airflow, and then the
Oh, okay.
Airflow URI. First, there it locks into the Airflow,
Yeah, yeah.
and then it triggers this tag.
Oh, I see.
ML. I also call it ML pipeline.
Yeah, yeah, yeah. Just coincidence.
Yeah.
Yeah, okay. I can see. I can see. You trigger the Airflow from the API,
Yes.
Flask API. Okay,
Yes.
okay. And the second
This part
question,
was
yeah, yeah.
very I don't know. I did not understand this really well in the beginning, and I don't because I when I tried it without Docker, the things were
Hmm.
working with no CSRF token. But once I Dockerized everything, then it needed a CSRF token. So I had to
Uh,
figure out how to get that.
I see.
Yeah, and it again looks through the whole HTML page and
Hmm.
finds value for the CSRF token. I guess it's a
Yeah, it's very
little
much like
secure like
a
that.
web scraping.
Yeah, yeah, it is.
You're web scraping on your own website, right?
Right.
Yeah, on your own website.
Yes.
That's funny. And then another question is because I'm not quite following how your
Oh,
model is built. So you show me like so you're doing a regression model, right? If I'm
yes,
understanding correctly. So
yes.
what are the features you used, and what is the label in your model?
Yeah, so that corpus I showed you here,
Yeah.
uh, so for each word, the features are these frequencies.
So
Okay.
there are many different colors of numbers. These are all the features, right?
Yes, those are the features exactly. And you
Okay.
see, this is the one we are interested in. The frequencies in that file are in blue, and they appear everywhere. But then
Yeah.
many of the other numbers are zero. Zero meaning missing here, but then I impute them with zero. Because those words do not appear in the whatever.
So each column is a different CSV you mentioned here, and
Yes,
each
exactly.
row is a word. So it's more like a frequency table,
Yes, this is
frequency
the
count
frequency
table.
table. Yes.
And did you use something called TF-IDF? It's
But
a TF-IDF. It's more like an NLP model. So you're not NLP. You're not using the NLP,
yeah, there is
natural
no
language
NLP
processing. Oh,
here.
okay.
What's that library called?
It's not library. It's called a model. It's called a TF dash IDF. So it's
EF IDF. Okay, I
yeah.
can
You
look
can
that
take a
up.
look. It's like a do very similar to what you are doing, but it's more like a feature engineering for text,
Okay.
and it's using frequency counts
Hmm.
and to build them all. I really think you can take a look at that because that one
Hmm.
actually helps you to do feature engineering. And the output of that is very similar to the table you're showing here. It's more like a frequency, count and frequency tables for each different word. But you can take a look how that is built.
Hmm.
Mm.
One, I looked at some tools and libraries, and if this was a project in English language, I could have used many more things. I
Yeah,
didn't even need to build my, like here I have a whole, where are those files? Like all that corpus I downloaded, and then the word frequencies here, or all
yeah.
these are the files from where the
Hmm.
columns are coming.
Each one is each column on the ML
Yes,
import.
exactly,
Okay.
right. And here,
Yeah.
what each file means is this is a, uh, like the type of writing, like these are stories by a particular writer,
Okay.
and this is a
I see.
novel by another writer.
I see. I see. And you're doing the word count
Yeah,
inside each of this. Yes.
right.
Okay. Great. Great. And and all your like the HTML part are using the Flask to using Nginx to serve, right? The static. part.
Yes.
Okay, goes through
Yeah.
Ninjax.
Yeah, although I'm using with this port with the IP address, uh,
Mm-hmm.
but probably the university network has some firewall because I can only access it. Even though, like you see, this is not localhost. This is whatever the IP address.
Okay.
I cannot access it from elsewhere, and I suspect that might
Oh
be
yeah.
because this is
You can
university.
specify the IP of your fast API to be 0.0.0.0 instead of localhost. Localhost is 127.0.0.1, which is a protected address from outside the machine. You can only access locally. But if you
But
put it like a 40, I mean
uh,
the
but
IP.
okay, but this is not really 00. This is the external address.
Yeah, I know, I know. I mean, you host it on the external IP address,
Yes.
and but when you start a server on that address, the IP address is 40, and you can access it from anywhere, like as long as you can connect to that network.
Oh, when I start, but shouldn't that be by default be 0?
I'm not sure by default which IP address it is using. Maybe localhost, and
Okay, I'll need.
yeah, but
Okay.
you can figure that out. But this is one
Hmm.
possible reason why you cannot
Okay.
access it. And okay, so your Docker Compose contains everything. And
Yeah,
did you Dockerize your model part? So your model is like
mod
running, yeah,
model is running in the web server.
web server. Okay, so share
Yeah.
the same Python environment as the Airflow.
In the Airflow web server. Yeah.
Yeah. Okay,
Yeah,
okay.
yeah. They are. It builds an image here in the Airflow, and
Yeah,
there it
yeah.
it installs some. Where's the Docker file? It
I see.
installs some libraries which are
Yeah.
required for
Exactly.
Python, like scikit-learn and MLflow.
Mm-hmm. Okay. Yeah, got it. And your ML flow is hosted locally, and
Yeah,
uh,
Airflow and MLflow, they are both local.
yeah. So for the ML flow, where did you store the actual model artifact?
Yeah, those are here, ML runs and ML artifacts.
Okay, you use okay, so you do a volume mapping, so it's mapped to your local environment.
Yeah,
Okay,
yes.
I see. Okay, so sounds good. Sounds as long as you have a volume mapping, you are not losing it.
Right.
Yeah. Otherwise, every time you start, it's wiped out. Okay, so very impressive. Like I didn't expect that you even have a UI, a web UI build. Do you have a web engineer background? Do you?
Sorry?
Do you have a web engineer background?
Oh, no, I do not.
You
But
do not.
I had to when I was making this file, which is not hosted anywhere, but I was converting all the poems into an HTML format. Then I learned
Hmm.
a little bit of web designing just
Uh,
to make this thing. Uh,
yeah, because I already see some interactions on the HTML. Like the user
yeah,
click the button and the button
right.
state keeps there and the send API request. Yeah, it's amazing. And yeah, so I didn't really expect you can bring this up and trigger the airflow from the code basically. Okay.
Yeah, it was a bit painful, but in the end it
Yeah, but
worked
in the
out.
end you
So
work it. So
it's
I
fine.
hope you learn something from this
Yes,
this
of course.
bootcamp. Yeah. So MLflow, Docker, and Airflow. Yeah, at least I see three. Yeah, I only asked for two, maybe one, just only one, but you did three. So amazing.